Chapter 5 deals with inverse trig functions. Okay, now if you recall back in when we were talking about functions, right? Inverse functions are those that undo what the function did. And also, the only time an inverse of a function was also a function was if the function was injective, that is 1-to-1. But you notice that trig functions are not injective. In other words, there are two values of x that give me the same value of y. For example, sine of 0 is 0, and sine of pi is 0. So trig functions are highly not injective, so we have to jazz them up a bit to get inverse functions out of them. And the way we jazz them up is we limit the domain of the trig function, which limits the range of its inverse function, so that we only get one answer out of an inverse function. All right, and I like to point out that sine, whenever the -1 is right here, this is the arc sine of A, or the inverse sine of A. It's not 1 over the sine. And that's a common error. And by the way, there's two ways to write it. One is this way, and the other is arc sine of A. And they mean the same thing. Okay, so you can either use this notation or this notation, and you'll see both. All right, so how do we jazz things up? Well, we jazz things up by saying, okay, the arc sine only kicks out values between minus pi halves and pi halves. Because in here, there's only one value possible in each case. Okay, so we limit the arc sine and also the arc tangent and the arc cosecant. They can only kick out values between minus pi halves and pi halves. Notice that minus pi halves and pi halves is exactly the set of angles whose cosine is greater than 0. So the arc sine only kicks out angles where the cosine is greater than 0. All right, and I'm going to claim you do not understand the inverse trig functions unless you know what values they can take on. All right. By the same token, the other three inverse trig functions, arc cosine, arc cotangent, arc secant, can only kick out values between 0 and pi. And by the way, the angles between 0 and pi are exactly the set of angles where the sine of theta is greater than 0. All right, so the arc cosine only kicks out values where the sine is greater than 0. The arc sine only kicks out angles where the cosine is greater than 0. All right, so that's something to keep in mind. All right, let's go to example 1. I want the arc sine of 1. What does that mean? I want an angle whose sine is 1, and that angle has to come from minus pi halves to pi halves. In each case, there's only going to be one answer that's correct, right? So what angle gives me a sine of 1 between minus pi halves and pi halves? And the answer is pi halves. All right, let's look at another example. Suppose I want the arc cotangent of the square root of 3. What is that asking for? The angle whose cotangent is the square root of 3 and what? the arc cotangent can only kick out angles between 0 and pi, right? So between 0 and pi. Now, I think about cotangent of the square root of 3 in terms of common trig values I know, and I can write square root of 3 as square root of 3 over 2 and 1/2. Right? Those are associated with a common angle. So I want something, and cotangent is what? Cosine over sine. So I want something with cosine root 3 over 2 and sine 1/2 that comes from the interval from 0 to pi, right? Well, cosine of square root of 3 over 2 and sine 1/2, there's only one angle that fits that bill in there, and it is pi over 6, right? So the inverse trig functions, we're really not doing anything different. We're just looking at the inverse problem. I give you a trig value, and you give me the appropriate angle. Now, sometimes we can do a little function composition thing happening. Suppose I want to compute the sine of the arc sine of a third. Okay, so what is that question asking? It says, give me the sine of what? An angle whose sine is 1/3. Well, what is the sine of an angle whose sine is 1/3? Gee, I think it's 1/3. I mean, who's buried in Grant's tomb? I think it's Grant. And whenever you have it this way, you just get the same value out. And what do I mean by this way? The trig function, the arc trig function, and then the value. Now, since trig functions, though, are not injective, you don't always get the same thing out if it's reversed. So, for example, what if I want, this is example 4, the arc sine of the sine of 3 pi over 4, right? See, here I have the trig function and then the inverse trig. Here I've got the inverse trig and then the trig. Here I have to be careful. I would like to write just what? 3 pi over 4. The problem is the angle here has to come from minus pi halves to pi halves. And 3 pi over 4 is not from there. Okay, 3 pi over 4 is not in the interval from minus pi halves to pi halves. So that cannot be my answer. Instead, I want another angle that's got the same sign as 3 pi over 4, but it's in this piece from minus pi halves to pi halves. Well, 3 pi over 4 is in quadrant 2. It has a reference angle of pi over 4. And so what I'm saying is sine of pi over 4 is the same as the sine of 3 pi over 4. And pi over 4 is in this appropriate spot. That is between minus pi halves and pi halves. So the arc sine of the sine of 3 pi over 4 is not 3 pi over 4, because that's in the wrong spot. It's an angle with the same sign. And what is that angle? Pi over 4. And the last example I'm going to look at is when I really start mixing things. And oftentimes you're not going to be able to compute these if I just give these angles as arbitrary, but in this case I don't. Suppose I want the arc tan of the sine of pi halves. What's that say? Give me an angle whose tangent is the same as the sine of pi halves. Well, so here's a way you can think about that. The arctan of the sine of pi halves is the arctan of, and what's the sine of pi halves? It's 1. So now I want the arctan of 1 What is that? An angle whose tangent is 1. And of course, that angle has to lie within what? The arctan only kicks out angles from minus pi halves to pi halves. So give me an angle whose tangent is 1 from minus pi halves to pi halves. And the answer is pi over 4. Okay, I think that got you going on the homework in chapter 5. Bye.